In this example, a diffuse surface at 1600 kelvins is suggested to have the spectral hemispherical emissivity shown as follows. Spectral hemispherical emissivity would be emissivity as a function of the wavelength, because we're including the word spectral here. So here you can see that your emissivity as a function of lambda is given to you. You have emissivity 1, emissivity 2, and then from lambda after 5 micrometers, your emissivity is actually 0. There is not going to be any emission at those wavelengths. But at wavelengths from 0 to 2 and from 2 to 5 micrometers, you do have some emissivity, or there will be some emissions. Now the lambda 1 and lambda 2 are given to you here and also listed. So this is lambda 1 and lambda 2, and your temperature is given. What's asked of you is total hemispherical emissivity, which we already know a relation for, and then total emissive power. If I can't calculate emissivity in the first part, I should be able to calculate total emissive power by just multiplying emissivity to my black body emission, which would give me total emissive power. So the biggest problem is to calculate the emissivity, then the part 2 is really easy. So we have this relation for the total hemispherical emissivity. It's basically your emission as a function of lambda and temperature multiplied by your emissivity as a function of lambda and temperature, and integrating that over the entire range of the wavelengths, and then dividing that by your black body emissivity. Now, if I want to look at this integration, I have emissivity, I have to replace that from this graph. The graph has 3 sections. One section is from 0 to 2 wavelengths, and then the other is from 2 to 5 micrometer wavelengths, and then from 5 to infinity, I'll just have 0 emissivity. So if I want to substitute these 3 sections in my integration, it will actually be 2 actual sections, because the third one, the emissivity is 0, and it will cancel out everything. So if I want to break down my integration, I'll break it down to 2 sections. I'll break it into 0 to 2 and then 2 to 5. And then during the 0 to 2 wavelengths, my emissivity is known to me and it's actually constant. It doesn't really vary with lambda anymore. So in those cases, your emissivity actually comes out of the integration. The second one, from 2 micrometer to 5 micrometer, again, the emissivity comes out of the integration because it's not a function of lambda here. And then these values I actually know. It's going to be 0.4 from the graph and then 0.8. So these 2 values I know. Now to take care of the integration, I don't quite have the emission here, but I do know that this relation, I know from the past that this looks familiar. This is the ratio of emission from wavelength 0 to wavelength 2 micrometer divided by the emission over the entire spectrum of wavelengths. The second one is emission from wavelength 2 to 5. By the way, these are emissions of black body, divided by total emission of black body over the entire spectrum of wavelengths. This is all those ratios that we defined in the previous lecture, and we know that these relations, the values are actually evaluated in the table. So I'm going to substitute them with the F values that we came up with last time. If you don't remember how this was done, go back to the previous lecture. So this was basically, this F was the ratio of emission of a black body from wavelength 0 to 2. In this case, it's 0 to 2. And it's a ratio, the ratio of emission of a black body from 0 micrometer to 2 micrometer divided by the emission of a black body over the entire spectrum of wavelength. And similarly, the second one would be from 2 to 5. And we said that these F values are always evaluated as 0 to a value. So for 0 to 2, I just go to the table and get that value. But for 2 to 5, I can't quite get that. There's no value for it in the table. So we said that we calculate from 0 to 5, and then from 0 to 2, we deduct it. Again, I have to advise you to go back to the previous lecture if this is not clear to you. The last example of the previous lecture is on this material. So we go to the table. In order for you to actually get the F values from the table, you do need to have your lambda t. We calculate those for the 2 cases, for lambda 1 and lambda 2. Once you recalculate it, you have 3,200 here and the 8,000 here. So based on these two values from the table, you should be able to get F values as 0.3 and 0.8. These are ratios. They can never become larger than 1. So the 0.3 and 0.8, you substitute them back in the relation. The 0.4 is already known. That's emissivity 1. And then F0 to 2 is 0.318. And then the second emissivity is 0.8. And F0 to 5 minus F0 to 2, and that should give you 0.558. The 0.558 emissivity that we've calculated is basically your total hemispherical emissivity. We can now use it as a representative of emissivity for the entire spectrum of the wavelengths. So now if I multiply that by the emissivity of black body, I should be able to get the emission from my surface over the entire spectrum of the wavelengths. So that is what I'm doing. I'm calculating emissivity, and I'm using it here, multiplying it to the emission of the black body, which is basically Stefan-Boltzmann constant multiplied by your temperature to the power 4, in order to calculate the emission of my surface. So this is the emission of the surface that we have, and this is the emissivity that we just calculated, Stefan-Boltzmann constant, temperature to the power 4, and that should give us the emission from this surface at 207 kilowatts per square meters.